Now that we've created our adaptive component, we can look at how we can bring it into a Revit model and use Dynamo to manipulate the different parameters that we've set up for it. So let's start out by creating a new conceptual mass that we'll use as our main Revit file here. So I'm just selecting new conceptual mass and selecting the mass template. Say open. Alright, once that's open, we should be working on the base plane, so we'll set the base plane just to make sure it's there. And then we can go ahead and start making a mass. I'm just going to select the rectangle tool and create a quick mass here. I'll select my rectangle that I've drawn and say create form. Extrude the form up by selecting the Z-axis on the gimbal. Now to make this form a little more interesting so we get some variation across the solar analysis we're going to be doing, I'm going to select the top face of the form here, and then I'll select the rotate tool. I'll allow it to snap to the 90, and then I'll just rotate it by, say, 20 degrees. Just a little bit of rotation here so we can get some variation. Alright, so now that we have our mass, we can go ahead and open Dynamo. The newer Dynamo should be under the Manage tab. Select Dynamo. I'm going to create a new Dynamo file. Okay, so to get started, let's take a look at the way that we can start to bring this geometry that we've created here. I'll just move this over to the side. Let's look at how we can start to bring this geometry we've created into Dynamo. We'll start out by selecting some of the faces, so I can right click or I can type up here in the search bar and I can say select faces. I'll use this to choose the faces I want, the faces of the solid object we've created that I want to actually make an analysis on or create the analysis for. So I'll say select, and I'll just select two of the faces of my mass here, and then I can click finish in the top left corner on Revit here. This is kind of hidden, but it pops up there, so you want to select it there. Okay, so now if we click over to the geometry view, we should be able to zoom out and we can see the faces that we've selected. Okay, now clicking back into the node view, we have our faces. Now I want to make sure that our faces come in flat as a flat list. So I'm just going to go ahead and flatten the list just in case. This might not be necessary. But we should be able to see now, since we're on automatic run, we should be able to see now that we have a list of two surfaces, and I can actually turn the preview off for the original ones. Okay, so our two surfaces are in that we want to create our analysis on. So let's start off with creating this analysis in Ladybug. I'll actually move this over so we can have more of our screen here. So to do our analysis in Ladybug, if you haven't already downloaded Ladybug, you can go to Packages, search for a package, and then type in Ladybug here, and it should be the first one that comes up. Download the most recent version. Also for this tutorial, we'll be using Lunchbox. So if you type in Lunchbox here, you can download the most recent version of Lunchbox as well. Okay, next thing we want to do is start our Ladybug analysis to get some test data on these surfaces that we can then use to drive our adaptive components we created in the last tutorial. So we'll start off by generating a set of test points on these surfaces. And so just like we said, we'll just search generate test points. Whoops. Generate test points, and you'll see that that's a Ladybug component, part of the Ladybug package. And so then our test surfaces are going to be our flattened list of surfaces that we created. And you can see that automatically it starts to generate. It has some default values, a 10 by 10 grid, and a distance from the surface of 0.01, and this just makes sure that the analysis isn't actually being blocked by the surface itself. Okay, so now that we have those test points, we can create our solar radiation analysis component. Solar radiation analysis, and this is going to take the list of test points and the point normals. So we'll also take a set of context geometries. So we see that currently there's nothing blocking the sun from hitting this mass. So actually what we can do, we want to add some context to our analysis. We can come in here, we could create another set of masses. So I can go back to create, for example, and I'll just create a couple of other geometries. And then I'll go in and just make each of these a form, extrude them up. So we can think of these like surrounding buildings or surrounding masses in the context of our building mass. Okay. Whoop. See, this is this is what happens when you don't select the actual plane first. I'll go ahead and delete these and make some new ones on the correct plane. So I'll go back and say set reference plane. Set reference plane, and then I'll draw profiles of the masses I want to use in this analysis. Okay, and then I'll escape out. I'll press create form. Quickly drag these up. Okay, great. Now they should be accurately placed. So let's go back into Dynamo now. In Dynamo, we can select some of the geometries that we want to use as objects that shade the building that we're actually testing here. So we'll start off by doing select elements. So we'll say select model elements. I'll click select, and then I'll, oops. Say select, and I'll drag and grab these four objects, which should be masses. And go ahead then, and I can say element solids. Put that in, and then that should bring these in as a set of 4 solids that we can use. So what we want to do is we actually want to flatten this list as well. We want to ensure that this list that we're providing as the context for our solar radiation analysis is flat list, so we'll plug that in there. Now the next thing that the solar radiation analysis requires is a filtered sky matrix. So let's go ahead and create one of those. So we'll type in filter sky matrix, also a ladybug component. So that's going to be plugged in here. Now we need to provide this with a couple of things. One is the actual sky matrix, an actual sky matrix, so we can generate a sky matrix. Generate sky matrix, another Ladybug component. We'll plug the sky matrix in there. Now the sky matrix requires a couple of settings. The most important one for us right now is the EPW file. So this is the environmental data that's associated with the location for your project. So where can you find the EPW file? Well, we can go to the internet, and one of the best places I've found to find them are on this Energy Plus website. If you actually search charlotte.epw, since we're located in Charlotte right now, you search charlotte.epw, Energy Plus is one of the first hits you get on Google. So if you go ahead and click on that, you can download the EPW by clicking here. Okay, so once we have our EPW file downloaded, we need to provide a file path. You can see that this requires just a file path to the EPW file. So you can do a file path component. I'll go ahead and browse and I'll find my EPW file. Okay, plug in my EPW file there, and it's going to take a moment. Since I have this on automatic, it's going to take a moment to go ahead and run the analysis. See that the generate sky matrix already has a series of default values that it uses for the other settings on the generate sky matrix. This can take a couple of minutes, so I'll go ahead and pause until it's done. Okay, so now our solar radiation analysis is completed. We haven't visualized it in any way yet, but we do have the data coming out of the solar radiation analysis component here. So the next thing we want to do then is look at how we can take that and first visualize it a little bit so that we can see what that looks like on our actual building surface. So next thing we're going to do is generate a set of colors and use them to change the display of the two surfaces that we've created. So we'll go ahead and do a generate colors, also a Ladybug component. We'll plug in our solar radiation analysis as the values for our generate colors. And the colors also requires a set of legend parameters. So this is basically a list of the different colors that Ladybug is going to use to actually make the display. So if we type in legend parameters very quickly, we can create that, plug that in there. And then for the set of colors for the legend parameters, we need to give it a Ladybug color range. You can go ahead and give it the default color range there. And you'll see it'll take a second. Okay, and now we can see by hovering over the index color range icon here, all the different color spectrums, you could say, that the Ladybug color range comes with. And so by just entering a number in here with the slider, or just by leaving it at default, we can use the color range we'd like, the set of colors we'd like to use. Alright, so now we've generated some colors. Now we need to actually display those colors on the surfaces that we have. So we can go up here and say display colors. And we can say display by surface colors. Display by surface colors, we'll take this color list that we've created, and then it also wants our original list of surfaces. Right? So now we can see that that's working in the background, but we have kind of an issue where we're seeing both of the sets of colors at once, the gray and the multicolor. So I can come back here and I'll turn off the preview on anything that has that actual geometry as part of it. Turn on the preview on this, turn off the preview on this, turn off the preview on this. Okay, so great. Now we're starting to see the actual colors of our analysis on our mass here, or on our faces of our mass that we've selected, and we can start to see the shadows actually of the other building masses that we've created in this model. So now let's look at how we can start to bring in our actual adaptive components that we've created and start to look at how they affect this this set of outputs here. So we'll start off by getting a family type and creating some instance of it. So go ahead and select family type. Alright, so we have our family types. So you see we have not yet actually brought in our adaptive component into this model, into this mass model. So let's go ahead and take care of that now. I'm going to start off just really quickly, save this. Minimize it down. Okay. So what I want to do is I'm also going to save this. Let's call it, we'll just call it city. Let's save it here. Alright, so then I'm going to go ahead and open my louver panel that we created and say open. Alright, and then from this I can say under modify, load into project, and that'll load it into our mass model. We could go ahead and place these now, but we're not going to do that yet. We're going to actually use Dynamo to make our placements on these. Oops. So I'll just switch back to our city. Oh, 1 second. It's kind of freezing on me. Alright, so now I'm switched back to our city. We can open up Dynamo again. Oh. Looks like it lost some of our selections. Probably should have taken care of that beforehand. So I'll go ahead and make our selections again. We'll say select face, and I'll select those two faces, say finish, and select model elements to include in our analysis, and I'll select these guys. Oops. Right? I have to wait for that to run again. Okay, so now that that's run, we should be able to select our drop down, and now we can actually see that our louver panel has become one of the options that we can select, our family that we created, which is great. So now we want to go ahead and create an adaptive component by points. So we'll say adaptive component by points here. And the family type we want to instantiate is this louver panel that we've created. Now we want to get a set of points. We need a set of points that go in that clockwise direction that we created our original adaptive points in. So we'll go ahead and use Lunchbox to generate those points for now. So with Lunchbox we can do a quad grid panel. So we'll do Lunchbox quad grid by face. Alright, so now we need to give it a set of surfaces, and we have this set of surfaces for our analysis already imported, and then we need to give it a number of U and V divisions. So we can create a slider for that. Will just be Actually, not a number slider, we need an integer slider. Integer slider. I'm going to go ahead and set this to 10, and then I'll plug it in for both the UA and the V here. Might take a second to run. Okay, now that it's run, we have a set of grid panels here. All right, the next thing that we're going to want to do is take a look at the structure of the list that's coming out of this grid panel. You can go ahead and do a watch component. Alright, so based off our watch component, we see that we have a list that contains another list that contains a set of 4 points. And so each one of these sets of 4 points represents one of the panels, and we can use each one of these sets of 4 points to generate an adaptive component. Now, the one thing we do want to do is because the adaptive component wants a two-dimensional array, meaning that it wants a list that contains sublists of 4, in this case, points, since our panel takes 4 adaptive components. The list that we're actually getting as an output from our lunchbox quad grid is a three-dimensional list, because it contains two lists, one for each surface, and then another sublist containing lists of 4 points. So we actually need to flatten this down one level, but we need to flatten it, basically flatten it from the top down. So we'll go ahead and do another list flatten. And you'll see that there's this second type of list flatten where where we have we can specify the amount. So you see the amount here. So we'll go ahead and select one of those. I'm going to change my run to manual at this point because I don't want it to run every time I select something, just for the sake of speed here. So we'll go ahead and bring in our list of points, and the amount we want to flatten it is just going to be 1. So I'll just do a code block 1 semicolon. Alright, so that should allow us to then get our flattened list. Let's run that just to see what it looks like. Great, so now we have our two-dimensional list. So our two-dimensional list of points can then be provided to our adaptive component by points. I'll go ahead and save this now because this can be kind of a costly calculation here. So we'll say run and see how long this takes. Okay, so this is finished running now, and you can see that it has created these panels. You can't see them in the Dynamo window, but actually if you minimize the Dynamo window, we can see that they are present in the Revit window. But there's a little bit of an issue, right? The panels seem to be going the wrong direction. We want these louvers to be sticking out from our surface. However, in this case, they're sticking inwards, so let's look at how we can flip that around. So basically, let's go back into Dynamo. And what we need to do is, before we provide the list of points to our adaptive component by points, we just need to reverse the orders of these lists so that it draws it the opposite direction. So I'll go ahead and do a list reverse here. Take our list, bring it in, and what we want to do then is change the lacing to tell it to look at every list individually. Go ahead and run this, and now we can see that what was the last item in each sublist has become the first item in each sublist. So let's go ahead and try that new list with our set of adaptive components and see if we can get them to flip. Alright, so now that's gone ahead and ran. So let's go ahead and look at this. Oh, minimize that. We can see that they flipped. Great. So let's go back and start creating our analysis that includes our new panels. One thing that we can do is we can set the actual parameter value of the length of these panels. So we'll go ahead and say set parameter by name, element.setParameter by name. And so we can take our series of adaptive components and we can say the parameter name that we want to change is, and we're going to enter a string here, so we want to put it in quotes. The parameter name, we called it depth. You have to enter this exactly the same way that you entered the name of the parameter in the actual adaptive component when you were creating it, or figure out what it is if it's not an adaptive component that you created yourself. Okay, so we're saying we want to set a depth, and like right now let's set that to just a set number for all of them, and we'll say depth is going to be we'll just do another integer slider. Integer slider, and we'll set it to say 3 feet. Let's run that. Oh, we'll do an issue here. No parameter found by that name. Okay, hold on 1 second. Alright, so the issue we're having here is that this is actually looking for instance parameters, and so because we set the depth as a type parameter, we're not going to be able to modify it this way. So let's try it a little bit different way. If we just go back into Revit, whoops, minimize Dynamo, and select one of our instances that we've created, we can edit that type, and we can change its depth here. So I'm just going to set it to something smaller than what it already was. 6 feet is a pretty large louver. I'll leave it at that. Okay, so I'll bring it back now into Dynamo. Now what we want to go ahead and do is start to let's look at what our analysis looks like now with our adaptive components included into our analysis. What is the surface going to look like with that new shading applied? So now that we've created our set of louvers, we can go ahead and create or provide those in with as part of our geometry for our analysis. So we have these model elements, but we want to create a list. Say list.create. Oh, where'd it go? There it is. List.create, and we'll take our original geometries, and we can also provide then our new geometries. And actually what I do want to do is flatten this. Before we do this, go ahead and save it, run it. Should see that now you have a list of, oh, what's going on here? It doesn't like it because it's calling it an adaptive component, not calling it an element. So let's get the faces of this. So we'll bring in our adaptive components. Try to grab the faces of it. So you can see now we have a list of 400 faces. Okay, so we'll bring those into our list create, and then we'll flatten it afterwards. Go ahead and save this again. It's probably going to take a minute to run this. Run it.